Alright, welcome back, Programming 11. This is our third tutorial on creating the Visual Basic Pacman game. Today we're going to deal with all of the stuff for getting your Pacman moving about the game board based off a collision and that sort of stuff and keyboard input. So far we've got our form created based off of the Excel document that you use to lay out your game board. We also did our variable declarations here. These are global variables right inside public class main. And then in the last tutorial, we went and did our main load event, which goes and loads up, preloads all of our pack images and ghost images. And then we have two parallel arrays dealing with our X and Y values for each of the wall pieces. We added the wall pieces to the form and to our array, did the same thing for all of our edibles, and then added them to the form as well. Today we're looking at moving our Pacman around. So I'd like you to create a key down event. In order to get that up there, you can actually type it out by hand, or you could just go to the top here and pull down the little menu option down here. We're going to click on main events, and then on the right hand side you're going to scroll down until you get to the key down event, which is right there. Once you double click on that, it'll bring up this header right here. Alright, so what we're going to do is we're going to use Windows keyboard buffer. So Windows in and of itself, not Visual Basic notwithstanding, it doesn't matter what program you're in, Windows is constantly checking your keyboard to see if you're hitting any keys. So, a couple, whatever, 1,000 odd times per second, it's checking the keyboard to see if any key on the keyboard is being pressed. What we need to do is we need to tap into that and check to see if any of the keys being pressed correspond to keys that we want to use in our game. For example, if the player or whoever's using the keyboard is touching the up arrow key, this is what we want to run. If they're hitting the down arrow key, we want to run something else. So it works like this. Again, it's continuously polling the keyboard buffer. Whatever key the user is touching gets stored in this variable here called E, this parameter called E. And we can just check to see what the value of that is. Each key has a unique kind of key code or key value. We just check to see what the value is. So in our game, we're only looking for the up arrow, down arrow, right arrow, or left arrow keys. And if it's any of those, we're going to hit it, and we're going to correspondingly change our next direction variable for our Pacman. So, for example, let me tell you, read this. If e.keyValue is equal to the up arrow key, keys.up, then set next pack direction to the string up. If it's keys.down, set it to down, right, set it to right, and so on. If it's none of those, we're going to set next pack direction to stop. So once you do that, you're going to store your next pack direction in here. And the reason why we want to have a next pack direction and a pack direction is to check for collision. Which we'll show you in the next function. That's it for our key down event. Oh, one other thing, is there's 3 states for any key on your keyboard. The key down state is the state when they first push the key down. The key press state is while they're holding it down, and then the key up state is when they release the key. We don't need pressed, we don't need released, we're only going to use the key down event, so when they initially hit the key, it's going to register the key down event. Those are subtly different things for different sort of purposes. For this particular example, or this particular game, we don't need them. Next function I want you to pull up is your Pacman clock tick event. So if you go back to your main form here, and double click on your pack move clock right there, it'll bring you to our pack move clock tick event. This particular event triggers whenever our pack move clock ticks. And our pack move clock is set to tick 10 times per second. Alright, so what we're going to do inside the pack move clock is we're going to check to see if our Pacman is, is going to collide with the wall and that sort of stuff. So the first thing we're going to do is we're going to update our counter. And it's really just a variable that we're going to count up with. And whenever it's an even number, we're going to use this to animate our Pacman. So whenever it's an even number, we're going to display one type of image. When it's an odd number, we're going to display a different type. So it starts off at 0, and it's going to display the one image. Then it ticks to 1, we're going to display the other image, and then back to 0, and then back to 1, and so on. We're going to use a hit walls routine. This is a subroutine that we're going to create to check to see if the next collision, that's that variable we have up here, pack next direction, if that's going to result in a collision with the wall. If it collides with the wall, then we don't want to move them there. If it doesn't collide with the wall, then we can go ahead and move it. We're going to check to see what edibles Pacman has eaten and play the appropriate sound files. And then we're going to check to see if Pacman has moved through the secret passage and move him to the other side of the maze. Alright, it's a relatively short function here. Again, there's our counter variable, and every time this ticks, which is 10 times per second, we add 1 to this variable. So it starts at 0, goes to 1, then 2, then 3, and after 1 full second it'll have a value of 9, and then after 2 seconds it'll be 19, and so on. All we're doing with that is we're going to use it to animate our images. So we're going to create an if statement right after that, and we're going to say if our hit walls subroutine, and we need to, this basically, all this function does is a bit of a black box design here. You're going to create this later. All this does is check to see if our Pacman has hit a wall. If it's hit a wall, it returns a true value. If he hasn't hit a wall, it returns a false value. So in order to determine whether he's hit a wall or not, we need to send it our current Pacman, his next direction, and the speed that he's moving. So if this returns a value of true, then this is what we're going to do. If it returns a value of false, then this is what we're going to do. So we're going to hop up out here. If we've hit the wall, next pack direction, and then if your next pack direction is the same as your current pack direction, stop moving your Pacman. Otherwise, move him forward. Maintain his current direction. So basically what that means is, if your Pacman is moving along on a pathway, and the next move is going to make him hit a wall, and he hasn't changed directions, then stop him. So basically, if he's coming up to a right angle and he bangs into a wall, don't keep moving him forward. Otherwise, keep moving him forward. We don't really technically need this branch here. I just put it in there for the sake of clarity. The next branch on this is when hit walls is not equal to true. That means we haven't collided with a wall. What we want to do is we want to set that next direction variable from whatever key that they were pressing to his current direction. Then we can go ahead and move our Pacman. So we'll move Pac, send it in the direction that we're headed, and then we need to send it the counter as well. That is pretty much it for dealing with whether we're going to collide or not, except we have to create our hit walls routine and our move Pacman routine. And we're going to do that after the next step. Last thing we do on our tick event is we need to check to see if our Pacman's moving out one of the secret passages. So if his dot left property is ever greater than 450, that means he's moving out to the right of the screen, and we need to move him off to the left-hand side of the screen. If it's less than -50, that means he's moving out the left, we need to move him to the right. And that's pretty straightforward. We're going to do the same thing, by the way, for our ghost. Oh, got some more stuff here. I forgot about this. We need to check to see if our Pacman has hit the ghost. So this is the routine that's going to determine whether our Pacman and our ghost have collided. We'll have to create that afterwards as well. So if this returns true, that means, or if it returns a value of dead, that means we've obviously hit the ghost. If it returns a value of ghost score, that means we've hit the ghost as well, except we hit the ghost while the power pellet timer is enabled. And that's it for that. The 2 times we hit the ghost, we can hit the ghost when we're not powered up, or we can hit the ghost when we are powered up. Alright, next bit is we're going to determine which edibles the Pacman has eaten. So we're going to hop in here, we're going to create a variable called edible of type string, and we're going to run through this eats whatever Pacman has eaten, whatever things he's touched that are edibles, and this function here will return what type of edible he's eaten. So all we got to do is check. If it's a dot, add 10 to our score, play the appropriate sound file. If it's a power pellet, change the score, play the appropriate sound file, and turn the power pellet clock on. If it's a fruit, where are we here? If it's a fruit, change the score, play the appropriate sound effect. And if it's complete, which means we've eaten everything in our game, we're going to turn the power pellet clock off, or Pacman clock off, turn the ghost clock off, and then just display a message saying that they've completed the level. Last thing we do in this subroutine is change our score variable. As the score is incremented, or not necessarily change it, as the score gets incremented, we're going to display the score value in our label property, text property of our label for a score. And that is it for that routine. So we're going to minimize this. And now we have to move on to our move pack routine. Actually, let's do No, let's do move pack next. All right, this one's relatively short as well. This subroutine simply moves our Pacman based in the direction whatever is stored in pack direction and animates our chomping motion. So we send it pack direction by value, and we send it our counter value by value as well. And we're simply going to go down here and we're going to check to see whatever direction pack direction is set to. If it's set to right, we are going to add our speed variable to our current dot left property, which moves it to the right on the x-axis. And then we're going to check the counter. If the counter is divisible by 2, which means it's an even number, display Pacman image number 4. That means Pacman's open to the right. If it's an odd number, we're going to display Pacman sub-0. And you're going to see this pattern for all 4 directions. Even numbers are going to display the direction we're headed. Odd numbers Even numbers will display the direction, odd numbers will display our base pack. And the same thing when our Pacman is headed left. Again, we're going to move them to the left, move the actual picture box to the left, and then we're going to check the counter. Again, if it's even, display the left movement image. If it's odd, we're going to display our base pack. And we repeat the process for our down image, for our down direction, and again for our up direction. Just pay close attention to the index value for the image that you're displaying. And in order to double check that, to make sure you got the right image, you can always go way back up to the top here, where we loaded our images. They're right here. Image 0, base pack. Image 1, up. Image 2, down. Image 3, left. Image 4, right. Alright, that's it for today. Next day we're going to move on to the hit ghost and our eating routines where you gobble down all the food.